Hey guys, Alex here from the Megacell Charger project. I want to give you some updates on the campaign we're running and I want to also give you some insights on a software that I've been working on to index batteries before processing them. So on the megacellcharger.com you'll see the crowdfunding campaign that we're running. It had some hiccups, but I think it's back on track now, and we're pushing it. I've got in touch with more people that have communities of do-it-yourselfers and stuff like that. Because before I was relying more on Facebook, but then I found out that there are other ways, and there are people that are doing this kind of project, do-it-yourself projects that are not related to power banks and stuff like that. So we did a campaign, and it's running great. And also I want to share something with all of you. If you have traffic and if you have a way to promote this kind of project, we set up an affiliation platform especially for this campaign. You can reach it to affiliates.megacellcharger.com. You can sign up. It's free to sign up, but you'll have to discuss with me about the source of traffic that you have, how you're planning to promote the product. So we keep it on a contained way, because there, from what I've heard, there are spammers and stuff like that. I'm sure it's not the case of everyone, but for that reason I will have to manually approve the account before using the affiliation link. So with these two out of the way, this is the main project right here, the Megacell Charger. And if you don't know about this project, I recommend watching the video. You'll hear about the story, how we got started, and what this hardware is capable of. In 2 words, it saves time, and lots of it. So let me launch the project that I worked on. I posted a few updates before, but right now I think it's ready to be used. It's not 100% there. I just spent a few days on learning what's up with this technology, neural networks. I train an algorithm to recognize the batteries, just showing them to the webcam. But yeah, the interface is fairly simple. It has a connection to a database, and let me remove all of these to start fresh. So you can set a project ID. I made it simple right now because I just want to index the batteries quick, get some data, and work with that. So the first thing is to start rec. Alright, so it launched. My plan with this project is to make it open source, but I must find a way to do a proper documentation to set this up, and there is a limitation that it requires a GPU to run on. It runs on CPU as well, but it goes with 1 FPS, like 1 frame per second. But yeah, let's see how this works. So I have this pile of batteries, and let's index it and see what kind of results can we get. All right. So if we train this system with multiple photos and have it set up properly, it can help when you are sorting out cells, and you actually know if those batteries are worth recycling on or not, because the plan is to index all this data and then use the Megacell charger to measure the data and get an average of cells recovery for these batteries. So we'll know for sure, okay, this kind of model will have 80% chances to be recovered. Like I said, it's not 100% there, but it serves like a good testing, and I learned a lot about the process of training this neural network. One thing that I will change on the next version is that I will set up a rig to have proper lighting, and also keep the webcam on a fixed angle. That will help to make this more accurate. And this one, for example, is not recognized properly. Okay guys, so I kept going and I almost got to the bottom of the sack. Yeah, I see some of the packs have like 5,500 milliamps, and that's because I was reading the watts hour. So it's not right, but they'll change in the database. For now, my aim is to get these into the database, test them and see what's the recovery rate on these packs. Because I talked with a lot of people and they always ask me like, okay, but how much you can get from it? From our small test, we got like 70 to 80% cells. But I would like to see it how it scales up. And getting more data is the only way to find out. This one doesn't want. Simple. It was getting it right, but I thought it's a different battery, so he was right and I was wrong. I was trying to correct it. If you see, it shows the model name. 59, it means the class name, like how I trained it, and 0.9 is the certainty that this battery is actually what was displayed on the label. Yeah, you can see it's recognizing it. It's actually this Li. Yeah, that goes into. Yeah, it says HP on the database, but these are actually compact, and the series is right. Maybe there was a model made by HP or something like that when I indexed it. Yes. Alright, so that's about it. We should have 481 cells and about 1000 amp hour worth of cells. Having this data, we'll find out like how many of the 481 cells will actually be usable and what's the total capacity that we will have from those cells. These are the batteries that got recognized by the system, and these ones on the right are those who did not get recognized. It's a fairly new system for me. I did not experience with training neural networks before. I'm trying to find how easy it is to use and if it's feasible in this kind of projects. Let me know in the comments below what do you think about this kind of solution for simplifying activities, and what kind of solution would you recommend using this kind of technology on, other than recognizes people on the street and stuff like that. That's not our business, but the technology is cool, and I think it has a lot of applications after people will figure out how to use it properly. What kind of setup do you need? What kind of training footage do you need to make this work properly? So yeah, that's about it for this video. Thank you very much for watching, and if you have any questions, feel free to ask. All the best, Alex.